Now we are just starting to record again our lecture. So we left that if you have used the order of approximation, it's coming from the big O, is coming from the first letter of order. Okay, order of approximation. If you want to use it with the order of approximation, oh, oops, again my computer is locked. Oops, it's nothing. There's a problem, guys. Huh, I got it. If you want to use here the order of approximation, it means that equality is acceptable, okay? Like the previous writing here. In the previous one, I want to show, but because of the technological problems we have met, okay, doesn't matter. So if you use here the without using order big O notation, so it should be corresponding to the approximation. The terminology is so important. So because if you use here the delta approximation, delta x approximation, it means that there exists remainder term for you, which means that this is my first term. And it also shows that, notes us, because the power is 1 in the order of approximation delta x, or in other words, guys, you can also use the first term in the previous approximation, the first term that you are obtaining here, the first derivative, which is your desired. This is your desired term that you want to get at the beginning. So the remaining part, after finding your, after seeing your, the thing what you desired for, okay, and the remaining part, the next first term of the remaining part will be the error of your approximation. So this error approximation, the power is 1. So power is 1 denoting us here order is 1. So in the engineering and applied sciences, actually, guys, order is so important for you and for us, of course. So because in engineering problem, generally you need to use here the big order approximations. Okay, so if your approximation order is getting increasing, so this will be helpful for your solutions because it is giving you a fast solution, as well as this you will also get here the more accurate solution, more correct solution. Okay, so for this reason, studying with higher order approximation is better for the choice. But of course, at the beginning of the term, all the time I'm saying you that when you are gaining something, you should pay also, you should give a pain, and also you should spend another thing. If you use here the order of approximation is biggest or bigger order of approximation, if you want to use, it means that you will pay here something to get this achievement. Okay, so we will discuss also in this process, in the analysis part, we will also discuss what we are paying it, okay, for this, for getting here the order of approximation getting increasing. So this is the thing that you need to focus on here. Okay, so one more exercise to understand the detailed discussion one more time. We will discuss here A0, A1 and A2 such that the given formula is here. Okay, we are discussing here A0, A1 and A2, which is represented by, guys, you are trying to approximate again. The left side says you here the approximation, what you want to approximate to. Okay, to what you are approximating. So the first derivative you will approximate, and the right side here is f of j, j plus 1, j plus 2 here. So by using some coefficient, please be careful and please notice that, guys, I have written here approximation. Why? Because there is no plus order of delta x to the power something. Okay, there is no, I don't know what is it, because of this I'm writing with the question mark, but doesn't matter. You are having, if you have here also adding order of approximation, then it is turning to equality. But because I didn't write order of approximation. For this reason, we are using the approximation. Okay. Furthermore, find the error term of the approximation. Okay, to do this, again, we're using the same procedure. What is the procedure here? Using Taylor series. Just use the Taylor series. Okay, when we are writing here f of j, f sub j, it denotes as f at xj naught. Okay, so fj plus 1 means that what? F of xj plus delta x, j plus 2 means that 2 steps later. So it means that 2 delta x I will go from my, from my location, I will go to 2 steps later version. So it is xj plus 2 delta x. After putting them into the Taylor series form, so you know that because of the formalization in the question, it is written as A0, A1, and A2. Guys, this is written in the question like the formalization as in that form. But in your field, for instance, later you need to create a difference approximation, okay, difference formula. For instance, you want to get, for instance, using 3 steps, and you are getting here the third order approximation, for instance. So you will do here what? You will use here, you will state your parameters. Alpha, beta, gamma, does not matter. A0, A1, A2, A3 doesn't matter. You will define here your parameters under which choices will give me here the total decision that I'm trying to obtain here. This is the thing. Okay, so A0 multiplied by f of j and f of xj, sorry, A1 multiplied by f of xj plus 1 and A2 multiplied by, as I solve in my equation, A2 multiplied by f sub j plus 2, which means that xj plus 2 delta x. So by using here around xj, taking basis like xj, so everything turns to xj, the additional part will be dedicated for my, as my coefficient. So after writing and multiplying them, I'm going to do back again, reading my question. The question says you will add here A0 f sub j, A1 f sub j plus 1, A2 f sub j plus 2. After adding them, you will recollect all the common parameters. F of xj, f derivative xj, f double derivative xj. The other thing here is that what? You should have here how many parameters we have? 1, 2, 3 unknowns we have. Totally, which are mainly for us to observe here the difference approximation, the difference scheme to approximate the first derivative. Instead of derivative, I'm using here the scheme. So I have here 3 parameters. So what does it mean? Let me ask one more question. How many questions do we have here? Reply me. Thank you, Suleiman. Yes, 3. You are taken linear algebra and you are also already known everything. Yes, 3 equations are enough to solve the system. These 3 equations will be helpful for us, okay? So how can we deal with these 3 equations? It is corresponding to our assumptions. Okay, so on the right side, I have creating here my A0 f sub j, A1 f sub j plus 1 and blah blah, you can see that. And what is your purpose? Your purpose is to approximate, to define by using these parameters. I want to get f first derivative, okay? So I'm writing here first derivative and I'm having here the right side expressions which consist of infinitely many terms. So here we are starting with the equality. Let us start with the equalities. On the left side, starting with right side. On the right side, your system, your equation starts with f, right? Do we have any f on the left? Do we have any f of xj? No way. I don't have any f of xj. It means that this denotes us the coefficient of fxj will be 0. Okay, what about f prime? On the right, f prime xj, I have with some coefficient, but on the left, how many f of f prime xj we have? 1. So we are just writing here, it is now 1. Continue. It is not enough. Actually, guys, on the left side, I have achieved what I want. F prime is over. When you are seeing F prime, actually this part is over for you. From now on, the remaining part will give you actually the remaining part of the expression or order of approximation. But don't forget, I have also known that to solve such this system A0, A1 and A2, I need to obtain here 3 equations, okay? 3 equations. How can I do this? I can assume putting extra assumption, okay? Now, we know that because actually this part is enough. One more time, I'm emphasizing this one. I have observed f prime, this is my desired one, okay, desired expression that I want to get here, and I have obtained here the first derivative on the right side. This part is the stopping place for me, but because my system consists of 3 unknown parameters, to solve it I need 3 equations. So to do this, for this reason, these 3 equations coming from one more assumption, adding one more assumption, which means that this should be 0 because I don't see on the left side second derivative. There is no more second derivative on my left side. So when you are writing it, so there is no more, so it should be 0. Don't forget, I don't write all the terms as the 0, 0, 0, 0. I don't deal with it. I am just trying to solve 3 unknown parameters. To solve them, to find out a unique solution, I am putting here extra condition. Okay? So after writing these expressions, you can see that here your expression is corresponding to, for instance, starting with A1 and A2 representation. So you can follow the solutions, as you know. This is just the basic calculation. So when you're writing it, you will observe that A2 becomes minus 1 over 2x, A1 becomes 4 over 2x, 2 delta x, and A0 becomes minus 3 of 2 delta x. So what is your error term then? So the error term is what? After writing here, putting your expression, this is accepted as 0. The other remaining part, now guys, look at here. When you are writing them, this one is used, okay? The second one is used like here. And the third one is used to find out the unique solution for solving A0, A1, and A2. The remaining part is coming from this investigation. So what it says me? It says me actually A1 times delta x cubed divided by 3 factorial and plus from the second equation, third equation, A2 times you have already had here one more term. The term is approximated by what? 2 delta x to the power 3 divided by 3 factorial f third derivative at, of course, xj. So on. Don't forget, we have infinitely many terms. So if we need to obtain here extra term, I'm taking from my right side. Okay, I'm getting here my right side, choosing my term by term. I'm using all the terms if I need. So continue with your investigation. You have already found that your A1 and A2 respectively by substituting them into the equation, into the equation here, and you are getting here what? Your expression will give you 4 delta x squared divided by 3 factorial times f third derivative of at xj. So guys, okay, from now on, I am just defining my expression. Look at here, f prime xj. By our calculation, I have written a0, a2, a1. We have written all these things into the expression that I am having in my process. a0 fj, a1 fj plus 1, a2 fj plus 2, and plus order of what? The constant. You can also use instead of this as the maximum value of the third derivative. Okay, this is the third derivative maximum value is a constant. So I mean here you can write down it is less than or equal to blah blah. So totally you are focusing on here not the constants, you're focusing on delta x expression. So delta x to the power 2, this denotes you, because of the addition I'm using, this is equal. If I don't want to use here the order of approximation, then it is turning to the approximated value. What I can say about it, you can find out f prime xj here using 3 nodes, which gives you order of accuracy is 2. Okay, everyone. At that point, let me ask you first of all, in the calculation, do you have any question in the calculation process? Because we will discuss from now on something in the for understanding the idea. Do you have any question about it in the calculation? Give response. Who? Are you there? Süleyman, do you want to say here? No, I'm not there here. I'm not here. Or I don't have here. No question. Evet. Yeah, Betül, you may ask. In the totally. No, we have discussed actually because we have observed here. Let me show you. We have observed A1, A0 and A2 in our calculation. After writing them into the, look at here, into the expression in the question A0, A1 and A2 I have written, and then your scheme for the first order approximation is already, described as in that version. So we have found them. No, does not matter. Betül, you may ask in Turkish, doesn't matter. So Betül asked that, what is the problem? The problem arises in the totally case. She's asking that, just we are finding the formalization, or it's coming from where? So we are creating the formula. This is creation, okay? We are constructing here a formula for the expression. Okay, everyone? Okay, everyone. Now I want to get here a discussion, just trying to understand the idea behind it. Look at here. In the previous exercise, we have seen that 2 points f of xj plus 1. 2 points, by using these 2 points, I'm approximating to the first order approximation, first derivative. So in previous, we also observed that f prime can be at j, can be written as f of j plus 1 and minus f of j, okay, f sub j divided by delta x. This was giving you first order approximation. This was first order approximation in previous exercise. You may follow the previous exercise one more time. So here I'm using 1, 2, 3 points to obtain here first order, the same order, same derivative I am approximating. So increasing the points that I am using here causes, as you know, the increasing the order of approximation. So by using 3 points for the first order derivative, I'm getting second order approximation. Using here the first derivative again, using 2 points, again it gives me first order approximation. So when you are considering, as I said you, in engineering problems, this is the big thing for us. If I'm using the highest order of approximation, if I use it, so it is probably so good approximation for us. Accuracy is good, and also you are getting a fast solution, but the computational cost you are getting, you need to pay it. What is the problem? The problem, because of you are using just first order derivative, you will use here 3 points. These three points here will giving you extra calculation. Okay, so we did using here, of course, by using the unknown parameters maybe. So this is the problem. What I mean here, to gain something, to achieve something which is the order of accuracy for us, fast solution, accurate solution, and so on. So we need to spend here our computational cost. So for this reason, you need to prefer something. This is up to you. This is up to your model. Okay, so this is the thing up to here. I think for us it was the creation part. So I'm completing all the construction point. So from now on, you are familiar to how can you construct a scheme in the process. Maybe guys, it should be better if you want to solve some questions in the from your textbook, of course. Okay, and if you have any question, you may ask it to me by email. And I want to give you one more homework, but one more homework will come from, I think, in next week. Maybe I can give you. This should be better for your understanding. So I will also give a calculational question to you. So please do it, trying to do it on your own. Okay, do it on your own, just yourself. That's all. Okay, let's have a break at that point, because it's again almost 22 minutes, because of the uploading. As you know, on the UBS system there was a problem. I'm closing this session. We will continue in the next video. Okay.